For question number 10, the correct answer is 2.09. That is, distance between the two blocks at the said instant is 2.09 meter. And to show the steps of solution, first of all, let us visualize what happens after the two blocks collide. I draw a series of figures here. The first figure, one block attached to a spring resting on the floor, other block approaching it from the left side. I shall call this block in red color as block number 1 and this blue colored block as block number 2. Remember that in my reference. So for block number 1, we are told its mass m1 is equal to 1 kg. Its initial speed u1 is equal to 2 meter per second. Block number 2, its mass m2 is equal to 2 kg. Initially at rest, so u2 is equal to 0. The spring is massless, but its force constant k is given to be 2 Newton per meter. This floor is frictionless. You also take direction to the right as the plus direction for the help of calculation. Now, in my second figure, I show the collision between the blocks, and suppose it happens at time t is equal to 0. Now, after the collision, block number 1 in red color travels with velocity v1, and block number 2 in blue color travels with velocity of v2. But while block number 1 keeps traveling to the left in a straight line with the same velocity v1, because the floor is frictionless, the block 2 attached at the end of the spring performs a to and fro simple harmonic motion. Follow my cursor. So if I can draw another figure here, let us see what happens after some time after the collision. This block 1 keeps on moving to the left with the same velocity v1 as before. But the block number 2, as I said, at the end of the spin, performs a simple harmonic motion, that's a to and fro motion, about its original position shown by this double-headed arrow. To explain a little further, after a short time, the block travels maximum to the right, compressing the spring to the maximum. A situation like this, see here, block has gone to the right, pushing the spring to the maximum. This is the right end of its path, and then again it travels back towards the left, overshoots its position, initial position, and goes even further to the left, which corresponds to the maximum extension of the spring. If I can show that figure also, it is something like this. So understand these three things together. Originally here, this block, after the collision, goes to the right maximum, causing maximum compression of the spring, returns back to its original position where the spring regains original length, overshoots further to the left, goes to the extreme left where the spring's extension is maximum. This way, this to and fro simple harmonic motion keeps on happening about block 2, while block 1 continues to move towards left with a constant velocity of v1. Understand all these things clearly. The question is, when this block returns for the first time to its original position and the spring regains its original length for the first time, how far are the two blocks at that instant? Is the question clear to you? Now once this figure is clear, in step number 2, let us find out the velocity of block 1 just after the collision. And for that, the formula is v1 is equal to m1 minus m2 divided by m1 plus m2 into u1 plus twice m2 U2 divided by M1 plus M2, isn't it? And then putting the values, M1 is 1 kg, M2 is 2 kg. This 1 minus 2 divided by 1 plus 2. The value of U1 is 2 meter per second, that's positive towards right. So it is into 2 meter per second. And since U2 is 0, this term vanishes. We are having, this is coming out to be minus 2 by 3 meter per second. This minus sign implies that, as expected, the velocity of this block 1 in red color directed towards the left, and its magnitude is 2 by 3 meter per second. As we explained, although we have got a formula for V2, this velocity of this blue colored block, just after the collision, we don't require that. For the simple reason, this block does not travel freely. It only performs simple harmonic motion. So the next step is, what is the time period of that simple harmonic motion of this block attached at the end of the spring? And for that, the time period is given by t is equal to 2 pi square root of m by k, isn't it? M being the mass of the block, in this case I've taken it to be m2, and k is the spin constant given in the problem. So putting the values is coming out to be 2 pi into square root of, now m2 is 2 kg and the value of k is 2 Newton per meter. It's coming out to be 2 pi second. That's time period, but how much time is that? Follow my cursor. If we treat as a particle this block, originally at this middle position, going maximum to the right, returning to this original position, going further to the left maximum, then coming back to this original position. This much makes one oscillation, and time taken for that is one time period found here. But the question was to find out after how much time the spring regains length for the first time. So see once again, this particle initially here, this equilibrium position, initial position, travels to the right maximum, compressing the spring maximum, returning to its original position at which the spring regains its length for the first time. So time taken for that, going to the right extreme, coming back to the middle point, that time is half the time period. And that's why you can say time after which, there is a time elapsing since collision, after which the block 2 in blue color returns to its original position and the spring regains its original length. That time is equal to half the time period, capital T by 2. That is equal to pi second. And in this time, how much has this block 1 traveled from the place of collision? We're talking about this distance. Collision took place here and the block has now gone here. And this distance is the distance between the two blocks now. And that distance d is equal to V1, its magnitude only, into the time elapsed, that is small t, is coming out to be 2 by 3 meter per second multiplied by pi second. Pi is 3.14, coming out to be about 2.09 meter. And that is solution of the problem. We got that when the spring regains its length for the first time, at that instant between the blocks distance is 2.09 meter.